I specialize in test automation, as Lars said. I work for Praqma, and I've written this book a few years ago about how you can learn test-driven development with your team. That's something I've done a fair amount of, and I'm on Twitter. So now I'm at Praqma, but the experiences I'm going to be speaking about actually are from my last job, when I was working at a product company called Pagero. So I just wanted to tell you a little about Pagero so that you have some background. They have a cloud service, and the typical use case for this service is that some large company will call us at Pagero and say, okay, we're receiving all these invoices in various formats from all these different people. Will you help us so that we can receive all our invoices from you in the exact formats that we really want them in, so that they'll be easier for us to process? So Pagero says, oh yeah, fine, we'll phone all of your suppliers and tell them that they should send their invoices to us instead, and we'll forward them to you in the right format. And then, of course, additionally, we'll say to the people sending the invoices, you can send them in any format you like that's convenient for you, and you can make your processes more effective too. So the service that Pagero offers is basically integrating between businesses the flow of documents using the electronic formats. So about the company, we were about 45 developers, 7 teams. We had about 60 microservices by the time I left. But actually, the product was a monolith up until only 3 or 4 years ago. And it was in production for about 10 years, so we had quite a history. And this graph is anonymized for reasons of confidentiality, but you can see the trend here is the number of documents we're processing was just going up exponentially. So what triggered the whole move to microservices was basically that the monolith couldn't handle the traffic. We couldn't scale it horizontally any more than we were doing. We needed to start splitting up the pieces and giving more hardware to some parts of the processing. So we started out with this J2E architecture. This is Java with a Postgres database. So the first thing they did was actually put it in a Docker container. I'm sure there was someone earlier saying what a bad idea that was. But that's what we did. And the reason we put it in Docker was so that it would be the same to deploy as all of the microservices that we then built. So we started building lots of little new functionality in these microservices in Scala, also deployed in Dockers, and they talk to each other over Rabbit. So we could, all new features in microservices. And then we could gradually also start chipping blocks off the monolith and putting them into separate microservices too. So this enabled us to scale a little bit further, and then of course the database became the bottleneck, so then we introduced Cassandra and moved a lot of our data into that, because Cassandra is a data store that scales horizontally. So that's what our architecture looked like, and my job was testing in this thing. So before I start talking more about the testing, let me make clear what I mean by a microservice. So it's a piece of the system that you can deploy independently of the rest of the system in a Docker. It provides just one business capability, and the API to access it is very lightweight. And the reason it's called a microservice is not really to do with the size of the code base you've got in it. It's whether it's conceptually one thing that it's doing, whether you can understand what it does. So that's kind of the criteria for a microservice. I should also mention we had lots of teams working independently with different microservices as far as possible. And the team that I was a member of was the infrastructure and architecture team, which our job was to supply all the development teams with the infrastructure they needed for deployments and building and testing, which is where I came in. So of course we were moving towards continuous delivery at the same time as all this re-architecting. We had, for the monolith, a monthly release cycle, and we realized that a month's worth of changes is a big chunk, and if we could release more often, smaller pieces, that would reduce risk, it would decrease lead times, higher quality. You know, this has got lots of positive effects. So we wanted to do this. And we were largely successful, moving from monthly releases with those black stars, those are the hot fixes. We had a few of those. To 3 years later, we had a lot more releases in between, smaller releases. And we did manage to get rid of some of the hot fixes, at least. We did experience this change of more frequent releases led to actually higher quality because smaller pieces. So this is what we went through. That's what I just said. Monthly releases to much more often releases. So that's kind of the journey that we were on, giving you some background to what I'm talking about when I'm saying about testing in this context. So we're not Spotify, we're not Flickr, we're not that kind of enormous scale, but we are on a journey to continuous delivery and microservices, and have had some success. So let's talk a little more about testing then. So I like to talk about the test pyramid, because I think this is a good rule of thumb for helping you to think about some of the different kinds of automated tests you might need in your system. And it was Mike Cohn who wrote about in his blog that you need a lot of unit tests. Everything has units. And you need a few end-to-end tests that are going to check the whole system hangs together, that you also automate. And then this bit in the middle that he called service tests is the part that often gets forgotten, but actually it's really useful to have these kind of things that are a bit bigger than a unit test and a bit smaller than the whole system. So when I joined Pagero, they had actually a pretty good test pyramid, as I could see it, for the monolith. So they had lots of unit tests. The developers were writing unit tests for the code they were writing. We had a few GUI tests that would check the whole system end to end, including the user interface that was the whole thing. And then they had 2 layers in between, actually. Data layer tests for checking the ORM, the object relational mapping, and service layer tests, which were using an API to access one function at a time, basically. Tests for one piece of functionality through an API. So this was actually working pretty well when we had a monolith. But when we move to microservices, we find that this pyramid doesn't look quite the same. The end-to-end GUI tests are still valid, and the unit tests are still valid. But we found that the bits in between, we could change these. In fact, we needed to change these. So it became less important to just check the integration with the data layer. It became more interesting to look at the individual microservices and testing them in isolation of the other microservices. And instead of service layer tests accessing the entire thing, apart from the GUI, we started talking about system tests or feature tests, actually. And I'm going to talk more about them in a minute. So if we look at what it's like just testing one microservice, so this is the same slide you saw before. That's just taking one of these microservices and just seeing that thing works by itself. And these things are actually quite a convenient thing to test in many ways, because your microservice is independently deployable. So you just deploy this one service on your local development machine. Often a microservice has its own little database that it uses. So conveniently, you just deploy another Docker on your local machine with an empty database, essentially, for the microservice to talk to. And then you have your test case, which is then going to call the public API. I mentioned all microservices have a lightweight API that you can address from a different process. So the test case can be executed on your local machine, talking to the microservice running in a Docker on your local machine. And then, of course, your microservice might need to speak to another microservice to get its job done. That's a very typical scenario. And the test case, in some way, then has to mock that response to make sure that the microservice doesn't realize that the rest of the system isn't actually running. So you can trigger different behavior in your microservice depending on what the mocked collaborator is going to respond. So this turned out to be fairly intuitive and straightforward for the developers to get hold of as an idea. And they were starting to build microservices, and they were building microservice tests as well. And so my role in the architecture team, I didn't find they needed a great deal of support with this. You show the developers a few examples, and they were able to write this kind of test. Sometimes the mocking got a bit tricky, but generally they could do this. So the focus of my work was more on the business-facing feature tests that I mentioned before. This is a higher level of the pyramid. This is where you've got basically the whole system deployed, and you've got a test case in there who's trying to test that a whole scenario, a whole feature will work, that is going to talk to several services and databases and so on. And this is where it actually starts getting a bit challenging, and this is why I guess I spent my time on this more than the rest. So I want to say more about this part. So this is the example strategy that we basically had at Pagero. We're going to try and test crucial workflows, the happy paths, basically, for important features. We're going to use the APIs that we have available to us and build new APIs as we need them to access the functionality. We're going to try and avoid the GUI. That's really expensive to go through the GUI. And then we've got these 4 techniques that I'm going to go into more detail. And the whole idea of this is to try and cover the important features without the costs of maintaining those tests from getting too large. And this is what we came up with. So the first technique here, selective deployment. If I just go back to the monolith, when I want to test the monolith, I have to deploy the whole thing. And then maybe I've got 2 test cases that are testing different features that the monolith offers. But they're actually within the monolith. They're going through different modules within it. But because it's a monolith, I still have to deploy the whole thing. When you move to microservices, it's kind of in a way that in exercising one feature, it might hit some of the microservices and not others. So actually, when I'm running a test case, I can choose to not deploy the services that are not being hit. And that has a good property because it means that it's more likely I can then run that test on my local development machine. If I have to deploy 60 microservices, my machine will quickly grind to a halt. If I can deploy 5 or 10, then I have a good chance of being able to run that test case locally. And that shortens the feedback tremendously for me as a developer if I'm working on developing one of those services. So this is a slight simplification, of course. There are some essential infrastructure microservices that I will always deploy, irrespective of the scenario. So this is one area when testing got a little bit easier with microservices, because I can deploy less of the system and still test meaningfully whole features. So then, just reminding you again, the use case that we have for this system. This is the use case. Okay, there are others, but the basic use case is sending a document through the system and transforming the format and potentially adding data to the document as it goes through, and changing how you decide to process the document depending on the configuration of the person issuing it and the recipient. So very logically, it looks to me like this is a case where you want to do data-driven testing. So this is where basically every test is going to do the same workflow. They're all going to send a document through the system, but we're going to vary the details of the data, the properties of the issuer, the recipient, and the document. And we decided that each test case needed to control all of its data. So every test case would first create an issuer and a recipient with the exact properties that that test case wanted for that scenario it was going to test, and then send in a document that it had configured for that test and check that it was sent correctly. So that's the part that's not on the slide yet, if you realized. The data-driven testing says basically the data varies in every test case and the workflow stays the same, but data-driven testing doesn't tell you then how you check that the right thing happened. So that's a technique for handling test data. We need to decide how we're going to then verify that the correct thing happened. Because the thing is, you can go to the first line support and say, okay, what problems have you had lately? Which customers have been calling you and saying, our document's not being handled correctly? Okay, can I have a copy of that document? Can I anonymize it and create a test user with the same properties as the real user, and then I can trigger this problem and put that in my test suite. So identifying a new test case is a lot about identifying good data. And then, of course, creating the work is finding the data. And then you don't want to then put a great deal of work into writing by hand a bunch of assert statements about what should happen. So this is where we started looking at the three parts of the test. You've got arrange, act, assert. Data-driven testing gives you the arrange and the act, and not the assert. So this is where we went to approval testing. And approval testing is all about asserts. It doesn't actually tell you how you should set up the arrange and the act. So they marry together very well. So approval testing is basically saying, instead of hand writing out all the assertions, this is what should happen at the end of the scenario, you just say, okay, well, this is what it should look like. I've looked at this. The first time I run the test, I look at it. Does it look right? Great. Then I'll just do a diff the next time and check that it looks the same. And if it looks the same, the test passes, because it matches the approved version of the result. So I was using a tool called TextTest, which I'm one of the developers for, which is designed for exactly this kind of approval testing. And you might gather from the name that it's quite keen on text, plain text. In fact, I've got it saying that the recipient presentation could be a PDF. Actually, there are lots of different formats. It could be some XML variant or some proprietary format. But what we did basically was convert any of those formats to a plain text equivalent. In the case of PDF, there's a free utility that you can use, and then when you've got the output in plain text, then you can use a normal diff tool to check that whether it matches the approved version. So you convert whatever the important outputs of your test that you want to check, and you convert them to plain text, and then you can use an ordinary diff tool to decide if they match at a basic level. There's some subtleties to it, but I don't really have time to go into them. I've written extensively about approval testing. So anyway, the strategy here was data-driven and approval testing working together so that you didn't have too much work creating a new test case. It's mostly identifying data and being able to look at the result and see, is that right? Can I approve that? You want to minimize the test maintenance work by using tools that support this way of working. TextTest does support you a lot in approval testing. You need a tool for this. I don't advise you to just make your own. There are other tools available other than TextTest too. But the great advantage of approval testing then is that you have maximized the chances of finding something you never would have anticipated. If you have to hand code all those asserts, check that the amount of the invoice is correct, check that the bank account you're going to pay the money to is correct. These are things you really want to get right on your invoice. And if you're writing the assertion, you have to pick out some things. With the approval testing, then by default, you're checking everything. And it will also check if unexpected things appear in your invoice that you didn't have in your approved version. That will fail the diff. So you find bugs that you wouldn't have been able to find with just assertions, things you didn't anticipate. So this was a useful technique for us. That's 3 of the techniques I mentioned. I also wanted to talk about a 4th technique for debugging, because the thing is, the test breaks. There's a failure, the approved version doesn't match, and then you have to work out, well, where did it go wrong? In which of this myriad of microservices did the problem arise? So this is where we came to looking at the queue. I remember that all the services are talking to one another over a queue on Rabbit. And if you look at the Rabbit logs, you can see all the messages flying backwards and forwards. And this is a very simplified version of what the messages look like. But you can see that each message will tell you something about which business parties are involved, which issuer and recipient. And since the test has created those issuers and recipients, it knows what they're called, and it tags them with a unique ID, so that you know that the current run of the test case tagged everything with 1, 2, 3, so I can find all the messages in the queue that have that tag, and I can then pick them all out and put them in a log that is just recording all the events that were related to my test case that I just ran. So this will help you to debug what happened, because of course, usually if something goes wrong, a message is missing here, or a message is wrong here. So you can see at what point in the microservice architecture things started going wrong by identifying which message is wrong here in the log. So when I look at a test case in one of these feature test cases, it comprises all these things. It's the data, the small program that runs the workflow, the event logs that I can use to diff against when the test fails, the approved output, and then I also store the actual presentation in case the test passes when it shouldn't have, and I need to look and see what was going on or try and work it out. So that's kind of what we came up with for testing our whole features in the system. So I've got a few minutes left to just talk a little more about continuous delivery in this context, because of course your tests need to be run in your pipeline, and I usually use this picture to explain where the tests come in your continuous delivery pipeline. So your developers develop some code, they check it in, then it gets picked up by your automation tools that then run the unit tests. If they pass, we'll check that when you've built it into a Docker and deployed it, you can run your microservice tests, and then when you've worked out that they pass, then you run these system tests that I was just talking about, the feature tests, where you deploy potentially quite a few services, check that they can complete a whole business workflow. Then we might deploy the whole lot into a staging environment and have some manual testing on it before we feel confident to put it into production and monitor it, monitoring that it behaves well in production. So all the way down the pipeline, the environment you're deploying your code in gets more and more like production. You're testing larger pieces of code together, and the costs of the tests increase. The costs in terms of hardware, time to run them, and also maintenance costs, generally. As a rule of thumb, the bigger the scope of the test, the more likely it is to break, the more time you'll spend trying to work out what's going on. So this is kind of how I see testing in the continuous delivery pipeline. But this is a simplification for the case when you only have one team. Of course, I mentioned already we have lots of teams and working on different microservices. So actually the picture looks more like this at some level. And the area in the grey box is the area that the team has under complete control, because they're working in separate microservices. So the team has complete control over the unit tests and the microservice tests. But when you get to system tests, of course, then you've got more than one microservice deployed and probably services from different teams. So when we first set up our pipeline, we naively just had, every time things passed the microservice test, then they were all in system tests in the latest versions from all the teams. And we found that they broke all the time. This was a real problem. There was always some team who made a mistake that they didn't catch in their microservice tests. And they released this service that then caused everybody's tests to fail. And this became a problem for us. So we realized what we needed to do was, before we would let a team share their service with the other teams, they had to at least prove that it worked against the old versions of all the other team services, the old versions that we knew worked, because either they were in production or they were, in staging or something. They had been proven to work. So we basically extended the portion of the pipeline that the team had complete control over. We made them run their new version of their new service with the old versions of all the other teams' services before we would then let it come out and be shown to any of the other teams. So this is about where we got to when I left, actually, 6 months ago, that we'd realized that the team needs to be in control of more of the pipeline. But we were still holding on to this idea that we needed to test everything together in the same versions that we were then going to deploy. And at the scale we were operating at, that worked. We still could have a staging environment and we could still test everything there before it went out. But having done more reading around this and realized that actually this is a kind of a bottleneck, really. All the teams are sharing the same resources for system test and manual test, which means that if you can't infinitely scale the number of teams, basically, because they're all sharing this part of the process. So I think where we would have ended up, or maybe ending up for sooner rather than later, is that you extend the pipeline again, that the team also has their own manual tests of their new versions, and then they can ultimately deploy to production their new version of their service without previously having tested it together with the new versions of everyone else's services. So you're effectively putting into production something that's never been tested together with the other things before, which means you need these kind of things that we've been talking about, like incremental rollout, canary releases, and you really, really need this monitoring. You might need testing in production more generally. So as I said, we at Pagero, we didn't get there, but I think that's where you end up with when you actually start to scale microservices architecture and the teams working in that way. So that's my experiences. I always wanted to have one summary slide. I talked about the pyramid for a monolith and how that was different with microservice. I talked about how these techniques were used with data-driven testing, approval testing, and this tool text test, which I'm one of the developers for. I talked about testing in the pipeline, how you kind of, as you move down the pipeline, things get bigger and more expensive and slower, and how we realized that we needed to help the teams to be as independent for as long as possible in order to help them to move fast and get stuff out. So that's kind of where we ended up at Pagero, and I'd be very happy to chat with you afterwards if you have any questions. Thank you.